Okay, so what I'm doing here, I'm creating a little flat spot on the on this angled surface. I want to put a counter bore between this hole and this hole. The idea is the shaft that goes through here that supports the cam follower in there, I want to clamp that shaft so that there's no wiggle or play in that shaft. So I'm going to put a counter bore and a tapped hole, and then that'll get split, and then the axle that the wheel runs on will get clamped in there, and it'll be flush on the outsides. So I'm creating this little flat spot so that the drill will start nice and straight, and that and all I'm doing is go until it shows basically a full diameter, and then that's it. So that's all I need. I'll take that out and get the chuck back in. And that was just a little 3-flute carbide end mill, little corner radius on it. This is just a number 7 drill, tap drill for 1/4-20. Make sure my numbers are right. You know what? My arm's right in the view of the camera there. Let me move that a little bit. Well, that's really great video shooting there of Tom. Let's try that. Is it better? How about that? There we go. Okay, so I'm going to tap this little guy. Yeah, it looks like we can go almost to bottoming there. Okay, so next operation is going to be counter bore, but I got to counter drill it a little bit for this pilot on this. So in this case, I'm going to make sure that the drill is all the way up inside the chuck, bottomed out, because I want to hold a depth on this, and the depth I want is just a whisker past halfway here. Basically, I want this drill to just go halfway through there. So what I'll do is I'll just move it off to the side, and that'll be my depth right there. It's not critical, but let's see, that gonna work? Well, you know what? This pilot might be too long here. Farther. Like that. Let's try that. Make sure I go back, put it in position here. Alright, so now we're counterboring the hole that we put in there. So what I want to do now is go ahead and finish off that thread, and I'm just going to do that with one last little thread that didn't quite make it through. So you can see this tap is relieved behind the threads here so they can pass through that hole unimpeded. I have some that I've ground down, but this is a commercial one here. Okay, so that's it for that. Okay. Okay, so those got split on the bandsaw into my little relief hole, and they're counterbored and then threaded. That in there. So the idea is the axle that goes through here like that, and oh, there it is. The cam follower will be on uh-oh. Maybe I got a burr on there or something. Oh. Wow, that's a close fit. Okay, those fit the shafts really good. Anyway, the idea is there's two of these, and then once it's put together, we can tighten this screw up, and that's rigid in there. So this will be in between here like this, and we can squeeze these down and lock these, and there's no play and no chance for vibration. At least that's my thought. So that's why I set it up that way. Anyway, so these are almost done. There's another part that goes here that connects two of these together. We'll do that in a few minutes. All right. So this is the sine bar that we were using earlier to do the scribing of those angles. You know, you can also set things up here in the mill, obviously like that, and mill a precision angle. But you can see the height here. There's not a lot of jaw left once you start putting an angle on some stuff. So you know, sometimes it's easier just to do it a different way. Anyway, I mentioned you know, that I really like using sine bars because they're so simple and they're so accurate. The guy that I learned that from, you know, taught me to appreciate that simplicity and that ease of setup with the sine bar. Anyway, he since died quite a few years ago now, and I ended up with his personal sine bar, and there's kind of a great story that kind of goes along with it. I'll show you the sine bar first. So here's the sine bar that I got from him. This was his personal one, and his name's in there. His name was Fred. Anyway, it's a 5-inch sine bar. It's very low profile. Fits in the Kurt vise real nicely, and you can do some stuff in here with this. The story goes that he was taking he served the tool of die apprenticeship, and he was taking I don't know, some of his coursework or the machine work part of it. He had just started the course, and they were talking to the instructor in the class, and the instructor says, "Well, we're gonna work on a project in here. You guys will work on a project, and does anybody have an idea what they want to make?" So Fred raises his hand and says, "Well, I want to make a sine bar." And the teacher says, "Oh, well, geez, that's a pretty ambitious project for a beginner like that." Well, what he didn't know was Fred had already been working in a machine shop since he was a little kid. He worked in his grandfather's shop, a machine shop and fabrication shop. Anyway, he'd been doing machine work since probably, you know, since he could walk, he was hanging around that shop. So he had, at that point, already had a lot of experience. Well, the funny part of the story is that he goes home, right? He goes home and he's talking to his dad, and you know, his dad says, "Oh, hey, you know, how was school today, right?" And Fred says, "Oh, well, you know, they asked if we wanted to work on a, you know, what project we were going to work on." And he says, "Oh, well, what'd you tell him?" And he says, "I told him I wanted to make a Sine Bar." And his dad says, "Oh, you're going to make a Sine Bar, huh?" And Fred says, "Yeah, I'm going to make a Sine Bar." He goes, "Make two. I want one." So that's the great part of the story, is his dad already knew what his abilities were, right? So the fact that he was going to make a Sine Bar wasn't the problem. The fact was, oh, he can make two, and I could get one, and I won't have to make it myself, right? And so anyway, I believe that this is one of two that are identical like this. You know, it's, I don't know, 2 7/8 wide, and what is it? 7 inches long, and the rolls are about 3/4 of an inch in diameter. It's ground all over, very nicely done. It's got some tapped holes in the top, although I don't think I've ever used them. Anyway, I thank Fred for teaching me the appreciation of a Sine Bar, and I'm sure his dad was happy to get one of these too, just as happy as I am to have it now. So anyway, that's the Sine Bar story. We pretty much finished these up. We'll move on to the next part coming up in the next episode, and it's the connecting piece that connects two of these together. Actually, let me get two of them. I'll show you. So, yeah, move the camera a little bit here. So there'll be two of these like this, and there's a piece that goes on the end here that'll be milled out to accept that, and then this roller fits in here like that, and there'll be an axle that goes through there that's clamped. And I just realized I should have flipped half of these over so the screw was on the same side, but so you don't always catch everything. And this relief here is for this little threaded collar, which, oh, here it is. Anyway, this fits in here, and then the lead screw goes down in between those. Okay, so that'll be in the next episode. All right, so we've got the parts made for the steady rest roller supports. I went ahead and made these little guys off camera. You know, it's a pretty simple part, so no sense sucking up bandwidth with stuff like this. Anyway, these fit like this in the end of this, and they space this end of the assembly out. So I'll go ahead and put this together, and you guys can see how it goes together. I'm just using a shoulder bolt right now to space this apart. It'll have a flush fitting pin, you know, in real life. All this does is just hold the spacing of this end here while I work on it. So that fits like that. And what we're going to do is we're going to weld this to this, and then, oh yeah, the in and out movement will be like that. You can see that. So there'll be a hand wheel here that turns this screw here like so. There'll be a knob on this end. This will be threaded into the steady rest, and it'll move it in and out. It's a push-pull thing. All this collar does is provide a thrust surface to pull that out. And then on the sides we have the locking bolts will lock it in place. So what we're going to do now is get these tacked up for welding. You can see what I've done here. Let's see if you can see this. Actually, you know what? I'm going to put a clamp on that to make my life easier. Otherwise, I'm going to be chasing that thing all over the place. Easier for you guys to see. So what I've done here, I don't know if you can see it here, but I've left a little ledge for welding. It's just an edge prep is what it is. So instead of V'ing that out, I can just run a small fillet weld along there, and it'll lay in there really nicely. I don't know if I'm going to weld all that stuff. It just doesn't need a lot of weld, so you're generally better off, you know, the less welding, the better. So here's our roller assembly, and that'll roll on the material as we're turning it. So I think I'm just gonna try welding it along there, see how it behaves. Those will tend to want to splay these open, but that's okay because we'll be pulling it closed on this end here. I'd rather have it want to be a little open than want to be a little closed. So get this guy out of here. I don't need that. And we need that like so. And put the clamp on this side. And then sitting on the table here nice and flat, you know, registers all those surfaces together. So it's self-fixturing. That's what we call self-fixturing. You know, everything kind of lines up and locks into place. So that's kind of ready for welding. Huh. Okay, fine. That's all nice and flush. All right, let me get set up for welding. All right, so we're going to tack this up. Just 4 tacks on there. I think we'll just go ahead and take that off for a sec. And I think I'm just going to keep a little pressure on it. While we go ahead and weld that. So what I'm going to do here, so you see I got a tack on the end here and the end here, which was the convenient place to place the tack. But what I don't want to do is when I start my weld to go across here, what I don't want to do is just burn through that tack right away. So what I'm going to do is I'm going to start in the middle and then I'm going to weld out to this tack. And what that does for me is it allows me to get some weld material in there and strengthen this joint before I blow the tack away. So I'll weld from, you know, roughly the center line. Actually, I could even go over here, but I'll go center line just to keep things symmetric. And I'll weld out, and then I'll turn around and I'll weld out that way. So I don't burn those tacks right out of the gate. So it maintains its position, and as the joint gets stronger, I don't lose any position. So let's go ahead and do a little welding there. Actually, I'm going to switch glasses here. the same thing over here. This clamp is in my way now. Get rid of that. Probably all the weld it needs. See that? Let that cool off for a minute and I'll do the next one. So here we're making the little pins for the axle pins out of some 3/8 shoulder bolts. I'm just parting the heads off here. That's the sandpaper to break that edge. Now, one disadvantage to having a big chuck like this is that it doesn't go down very small. So we got to use this little collet block here to hold the pins. So I cut the head off there, and now I'll put a stop in the bottom of this and then cut them off to the right length the other way. So. Well, I went and looked, and I don't have a commercial collet stop that goes in a 5C. I'm just so used to having one at work, I never realized I didn't have one at home. So anyway, so we got to do it a little different way. So what I did was I just put a little bluing on there, blue Sharpie, and I scribed a little line. And so I'll just go ahead and part them off, and then I'll take them over to the mill and use a carbide end mill and machine them to length, and then put a 5C collet stop on my Christmas wish list, and get one of those so I don't run into this again, right? Huh. Alright. Rinse and repeat. Ah, chip that thing again. Look at that. You chipped that little peckerwood again. Damn it. Touch that up. Alrighty, so set up here.
Fresh from our farmers. That's ingredients for life. Safeway. What will be in your wine glass when you toast to summer fun? Red, white, or rosé? Well, Safeway is making it easier to consider them all with incredible savings. Just use your club card and you can save 30% on all wines. Plus, get an extra 10% off when you buy 6 bottles or more. Mix and match your favorites and save. Say cheers, it's summer to our wine sale. Save 30% on all wines at Safeway. Ingredients for life. 10% offer valid on 750 milliliter or larger bottles.
Courtesy Chevrolet, Northern California's largest Chevy store, with over 18
Okay, so this one needs about 8,000 taken off of it.
Silverados, starting at $11,000 net savings off MSRP.
Like that.
Experience courtesy
Let's see.
superior customer service when you buy your new Line 2 Rose.
Trying not to whack the camera here. You know, filming and working can be kind of a challenge.
Now through June 3rd, don't miss it.
Let's try that. Can you see anything? Yeah, I think so. Alright. I'm just going to go ahead and take the 8 after that touch up. Alright.
And of course, talk to farmers. Because the more you know about auto insurance, the more you can save. Get smarter about your
10. So that's actually, I'll re-zero that, so that should be good for the rest of these too. Take the side with the crappy finish on it. We'll do that.
Has your shot to win a family 4-pack of tickets to check out the new exhibit, Built for Speed, now open at the California Academy of Sciences in Golden Gate.